Okay, so we've developed an understanding of the strain versus temperature curve and thermal expansion versus temperature curve. But the question still remains, when do I use alpha instantaneous versus alpha average? And so this depends on several elements. The first one that I really think about is the material type. So if you're using a polymer or a ceramic or a metal, it's going to dictate where this transition occurs and whether or not this transition is important, because the strain versus temperature will change a lot more quickly in a smaller temperature range for a polymer, for example, compared to a ceramic. Something else to take into consideration is the temperature range. And when I say temperature range, I mean both the temperature interval that you're interested in, up at higher temperatures or in lower temperatures. So close to absolute zero, you're going to have a lot of trouble. At higher temperatures, you're probably not going to have as much trouble. But also that how wide a temperature you're using, 100 degrees C, 200 C. It just really depends on both the temperature range as well as the specific temperature you're looking at. The next thing I think about is length scales. So are your components small or are they large? And something that's kind of coupled to that, but not exactly, would be your tolerances. And something, for example, like an error budget. So if you have very large pieces of material, your strain is going to be produce larger changes in length. If you have smaller pieces of material, it's not going to be as big of a deal. And then if you have really tight tolerances or a tight error budget, you're going to eat up your error budget with large changes in strain. And so I like to kind of think of this in a table format. So if you look at the material and then you look at the important things for using the average CTE or the instantaneous CTE, you're going to kind of parse it into polymers, metals, and ceramics. Now these are very, very broad categories. You're going to find materials that will break these rules, but these are just simple rules of thumb. So for polymers, if you're using a temperature interval that's less than about 50 degrees C, then you can use the average CTE. If you have loose tolerances, and if you have small components. So those are the three things that I kind of think about. If you fit these three criteria, use the average CTE. But if your delta T, or your temperature interval, is greater than 50 degrees C, if you're in a temperature range from 0 Kelvin to pretty much the melting point of the polymer, or if you're using large components, then you're going to want to use the instantaneous CTE. I'm not really focusing on tolerances. You can't really get really tight tolerances with polymers, but the tolerance issue can come into play. For metals, The change in temperature, as long as it's less than 100 degrees C, you're probably safe. You can probably push that 125, maybe even 150. And if you're at temperatures on the order of 200K plus, then you're pretty well beyond this knee or this change in CTE, and you're in this almost constant CTE range. If you're using small components, or you have loose tolerances. Now, of course, it just depends on the specifics of your application. And so you use the instantaneous CTE if your delta T is greater than 100 degrees C. If you're in the 0 Kelvin to 200 Kelvin range, then you probably need to use it because of this very large change. And then if you have large components and you have tight tolerances. For ceramics, they're much more stable, and your delta T can be less than 150, sometimes 200 degrees C. If you're at 150 Kelvin plus, you're beyond that knee. Typically ceramics will show that knee at lower temperatures and stabilize more quickly than a metal. And if you have loose tolerances. Now, I haven't said large components or small components for ceramics. It's really hard to make large structural components out of ceramics, but so you're typically looking at small components just because the fracture toughness of a ceramic is not very good. And so if your, oh, that's a T. If your delta T is greater than 150 or 200 degrees C, if you're in the 0 Kelvin to 150 Kelvin temperature range, and if you have tight tolerances. That's kind of where I would use the instantaneous CTE for a ceramic. Now, these are rules of thumb, of course, but again, if you're using polymers, if you have a large temperature range, if you have large components, and you have tight tolerances, you're going to want to use the instantaneous CTE. If you're on the opposite side of the spectrum, using metals or ceramics, small temperature range, small length scales, and fairly loose tolerances, then you can use the average CTE very easily.